Alright guys, so we're in part 4 of our object-oriented programming video series, and we're going to talk about inheritance. Okay, so inheritance is actually a very easy concept to understand, and I'm going to show you guys how to implement this in practice. So the most basic example is when you are born, you inherit majority of the traits that your parents has, such as the hair color, eye color, nose, mouth, height, appearance, etc. And we can think of it the same way in terms of classes in object-oriented programming, where we can have certain classes inheriting fields from another class, not just fields, but also methods. Okay, any public class members, those classes can inherit those class members from another class. And this concept is called inheritance. It's the concept of inheriting all of the available properties from one class, inheriting it down to a subclass, so that way we can reuse those fields over and over again. So for example, let's say if I have an animal class. Technically a dog is an animal. Okay, there's no doubt about it. A dog is an animal. Does it make sense for us to create a new dog class, have all of the properties that the dog has when the animal already has it? Instead, what we could do is we can create an animal class, give it all of the base fields, give it all of the base methods, and then we can inherit all of those fields and methods in our dog class. Okay, so imagine you have a blueprint for a base house, like a standard foundation of a house, right? And let's say you wanted to create a new blueprint. Okay, well, you already have a basis of the house already, so the best thing to probably do is to extend the design and add more features, right? We can have a bungalow blueprint that is based off of our house blueprint. So instead of starting from scratch, creating a brand new blueprint, we can take our house blueprint and we can say, hey, look, this bungalow is going to have all of these features that the house has, but we're going to give it a bunch of other features that the house itself doesn't have, but only a bungalow would have. Okay, and we can also have our own cabin blueprint, an apartment blueprint, and many more different types of the houses. Now, in practice, we would typically have a house class, and then we would create a bungalow class. And since the house class can have a lot of fields and methods that can be inherited down to the bungalow class, right? The bungalow class can inherit all those fields and methods. They can share these properties. Then it makes sense for the bungalow class to extend the house class. So again, this means when you extend the class, all it means is to inherit all the available fields and methods so that you can reuse them again. Now, there are a couple things that happen when you do extend the class. So let's briefly mention them, and then we're going to go on to an example. So when you extend a class, now remember, extending a class just means to inherit all the fields and methods from that class. Okay, when you extend the class, you're creating an is-a relationship between them. Okay, between the extended class and the class that is extending it. The extended class is called the parent class or a superclass. Okay, they're synonyms. And the class that extends the class itself, the parent class, is called the subclass or a child class. Okay, so these terms are just very similar to real life scenarios, right? If you have a parent that gives birth to a child, the parent is the parent of the child, okay, and the child inherits all the fields and methods from the parents. Okay, and so just to briefly recap, extending a class is just creating a relationship. When you extend the class that you're extending becomes the superclass, the parent class, okay? And the class that is extending the superclass is the subclass or the child class. So there are a lot of different ways to call these classes. So just use whichever term that helps you remember the whole concept of inheritance. Okay, so let's take a look at some examples. Okay, so I'm going to go ahead and create a new file called animalclass.js. We're going to go ahead and create two classes. The first one we're going to create is an animal class, and we're going to create the constructor. We're going to pass in 4 values to this constructor. So we're going to pass in a name, color of the animal, height, and the weight. And then we're going to go ahead and assign these values that we're passing into their instance fields. So we're going to say this.name is equal to name, this.weight is equal to weight. Okay, cool. And we can even give our animal class a method. So we can give it a make noise method, and every single time this method is invoked, we're just going to go ahead and write this.name. Okay, and this is a very simple class. And if I were to create an instance of this class, and obviously this animal class itself is very vague because, it has no definition of what the animal is, has no property telling us what this animal is. But if we were to run this code, you can see we have our object logged to the console, which is pretty cool. But let's actually create a more specific class, right? Because we have many different types of animals. We have a dog, a cat, a zebra, a lion. Typically, we could add a field called this.type equals type, and then we could pass in the type as a parameter, which would be a string. Okay, and we can just say, hey, look, let's create a new instance of an animal, and the type is going to be a cat, and that type field determines what the type of the animal is. Now, you could do that, but again, now the whole point of object-oriented programming is to create these classes that can derive from other classes. Okay, so instead of having to keep everything in just one class, we can create another class that extends our animal class so we can inherit all of the animal's fields, all of its methods, and etc. So let's go ahead and create a dog class and extend the animal class. So remember, we can extend the animal class by using the extends keyword. And now you're probably wondering, well, what exactly does this mean? Well, the dog, since it's extending the animal class, that automatically means that the dog is a subclass or a child class of the animal class. And the animal class is a parent class or the superclass of the dog class. Okay, so dog inherits name, color, weight, height, as well as the make noise method. Okay, so now we're going to go ahead and create a constructor for our dog class. Now, before we can even set any fields on the dog class, because remember, there are some properties that a dog might have that not every animal is going to have. Okay, not every animal has a tail, so a dog does have a tail. Okay, so we might want to set a certain field on the dog. Now, before we even set any fields on our own dog class, we need to actually call the superclass, which is animal. We need to call the superclass's constructor, and we do that by referencing the super keyword and then parentheses. Now, if you have IntelliSense, you can see that it's showing us the constructor signature, and it's giving us the option to pass in these 4 parameters. So let's actually pass in those 4 parameters. But where do those parameters come from? Now, let's just say, for example, if I wanted to create an instance of the dog class, and I would want to pass in values into the constructor of the dog. So let's go ahead and pass in maybe a name, so Leo. Let's pass in the color to white dog. Height would be, let's say, 10, and the weight would be maybe 25 pounds. Okay, now these parameters are going to be passed into the constructor over here. So we need to take those parameters in. So we're going to do the same thing, name, color, height, and then weight. And what we're going to do next is we're going to go ahead and pass these parameters as arguments into the superclass's constructor. So basically Leo, white, 1025, these are all being passed in to our dog's constructor. And before we do anything else, we're calling the animal's constructor, the superclass's constructor. And you do that by using the super keyword. Okay, so now, if I were to actually log dog to the console, you're going to see that we have all of our properties assigned. Leo, color, white, height 10, weight 25. And if I were to completely just omit this, you're going to see that we have a bunch of undefined fields. Remember, all of these fields are being inherited from animal. So we don't need to create new instance fields on the dog class. We don't need to do this.name equals name, this.color equals color, this.height equals height, this.weight equals weight. We don't have to do that. It's not going to throw an error, but we don't need to do that. Because remember, we have all of the fields that are being inherited. And you're probably wondering, well, this is actually pretty cool. And it is, because this allows you to create more different types of an animal. So for example, we can create a class called cat and extend the animal class, because remember, inheritance is all about is a relationship. Okay, is a relationship. Cat is an animal, dog is an animal, but it's not two ways. An animal is not a dog, an animal is not a cat. Okay, a cat is an animal, but an animal is not necessarily a cat. Okay, because animals is a more generic type. Okay, and likewise, we can do the same thing. We can pass in the constructor. We can implement our constructor, and if we were to create an instance of cat, we would inherit all of the fields and methods from the animal class. So let's create a new cat class, or let's create a new cat instance and call this Lucky into black cat 8, and then let's do 7. If I were to log cat to the console, you're going to see we have a cat object and a dog object, and I can invoke their methods. See how I'm doing cat.makeNoise, instead of animal.make noise, we're doing cat.make noise because the cat class inherits the make noise method and all the other fields. And inheritance itself allows you to do one of the most important things, which is code reusability. Imagine if we didn't extend our animal class, we would have to constantly set the instance fields over and over and over again. So it's much better to create one base class and extend that base class so we can inherit all of its fields and properties. So I really hope this all makes sense to you because, again, inheritance is a very simple concept to grasp if you compare it to real life scenarios. So we can even give our dog class their own instance properties that an animal class might not have, because not every animal has spots, but maybe a dog might have spots, so we can even give spots and then maybe a tail property. And after we call the superclass constructor and passing all of the inherited fields, we're going to reference this.spots, so we're creating the dog's instance fields. And then we are assigning spots to this.spots and tail to this.tail. And we're going to create an instance of dog. We're going to pass in the name, orange, 15, and maybe 25 for the weight. And then the spots, we'll say spots, it has maybe 4 spots. And tail, true, it does have a tail. And now if I were to log this to the console, you can see our dog has all of these properties. It has the inherited properties from the animal class, and it has the dog has its own instance fields, spots and tail. Okay, and we can even create our own methods on the dog too. We can say, dogs can wag their tail. So we can go ahead and create a method called wag, and we can say if this.tail. So if it does have a tail, we're going to go ahead and do console log. And we can say this.name is wagging its tail. Okay, and then we can do an else case. This.name does not have a tail. Okay, and then we can invoke that method. So dog.wag. And let's just run our code again. You can see Leo is wagging its tail. Very simple. Okay? And that's pretty much the beauty of inheritance. And we can even continue down the inheritance chain by creating another class called maybe Labrador, or a specific dog breed that is a dog. Okay, so a Labrador is a dog. So we're going to extend the dog class. And now, if we want to implement this Labrador, we're going to do the same thing. We're going to implement the constructor. It's going to take in all of the inherited properties. And now we're going to just call a superclass. And maybe the Labrador might have certain traits, certain characteristics that not every dog has, and then you can assign the instance fields to whatever values you want. Because a Labrador is a dog, but a dog is not a Labrador, because a dog can be many different types. It can be a Shiba Inu, it can be a Husky. There are many different types of dogs out there. Okay, and we can do the same thing with the cat, and etc. And again, we can create an instance of Labrador, and I think at this point, you guys get the idea of inheritance. Okay, there are a whole bunch of things that you can do with inheritance, and it's pretty cool. So I highly urge you guys to think about real life objects, real life scenarios, and translate that into code, into object-oriented programming. So hopefully all of this made some sense. And if you have any questions, just leave a comment down below, and I'll see you guys in the next topic. Peace.